The market narrative around artificial intelligence focuses almost entirely on the virtual, software, advanced chips, multi-billion parameter algorithms. But every line of code written in the cloud ultimately runs on physical infrastructure. And today, the digital economy is colliding with a material reality it can no longer ignore. High-density AI campuses are fundamentally changing how modern computing is built. More computing generates more heat. Managing that heat requires larger substations, heavier transformers, more transmission lines, advanced cooling systems. Every one of those systems depends on one critical material: copper. As artificial intelligence scales, demand for copper is growing faster than new supply can physically be brought online. The digital economy is discovering something fundamental. Software cannot escape the constraints of physical matter, and that creates a problem the digital economy isn't used to solving. The challenge is not a shortage of technology capital. It is a profound mismatch of time. The technology sector operates in milliseconds. Capital moves quickly. Software can be deployed overnight. AI models can reach millions of users in days. But the physical world moves far more slowly. Bringing a new copper mine from discovery to commercial production takes, on average, close to 2 decades. Not 2 years, 2 decades. And while the timeline stretches, demand continues accelerating. The quality of known deposits is also declining. New supply is becoming harder to find and more expensive to develop. Major institutions tracking commodity markets expect the refined copper market to remain in structural deficit for years ahead. The bottleneck has moved from software to infrastructure, and now to raw materials. This is not simply another commodity cycle. It is a structural repricing of physical assets. When severe physical scarcity emerges, value rarely stays where most people expect. It moves away from the companies consuming the resource and toward the owners of the resource. That distinction changes everything. For long-term investors, the question is not whether artificial intelligence needs more copper. The question is, who owns the assets that benefit from that demand? Historically, major infrastructure expansions have rewarded 3 ownership models particularly well. The first is infrastructure royalty streams. Operating a mine is capital-intensive. Labor costs rise. Energy prices fluctuate. Construction delays are common. Royalty and streaming companies operate differently. Rather than running mines themselves, they provide financing in exchange for a percentage of future production at predetermined prices. They gain exposure to rising commodity demand without carrying many of the operational risks faced by producers. In a structural supply squeeze, that model has historically been rewarding. The second is grid modernization infrastructure. The enormous capital flowing into artificial intelligence is not simply buying copper. It is buying the systems that copper makes possible. High-voltage transmission equipment, utility transformers, substations, power distribution networks. Manufacturers that specialize in these critical components often possess years of engineering expertise, proprietary designs, and production capacity that cannot be expanded overnight. As demand rises, that scarcity can translate into significant pricing power. The constraint becomes the asset. The third is closed-loop reclamation assets. Primary mining is becoming more expensive. Permitting takes longer. New discoveries are harder to find. Development timelines stretch across decades. That increases the strategic value of secondary supply. Industrial recycling and metal reclamation networks can return critical materials to the supply chain without waiting for new mines. Companies that own these systems and secure long-term processing contracts are becoming increasingly important suppliers to the technology economy. In a world of constrained primary supply, secondary supply becomes structurally valuable. Now, it is important to hold this framework with clear eyes. Commodity cycles are not linear. Copper prices are volatile. Royalty structures carry counterparty risk, and recycling infrastructure, while growing, cannot yet replace primary mining at scale. But the structural direction, rising demand against constrained supply, appears durable across multiple scenarios. And that is what separates a cyclical trade from a long-term ownership thesis. If you only view artificial intelligence through a digital lens, you miss the physical foundation that makes it possible. The cloud runs on power. Power runs on physical matter. And physical matter is becoming increasingly scarce. That imbalance is reshaping how long-term capital is positioned. Value is migrating down the stack. The most durable returns of the next decade may not belong to the companies writing the code. They may belong to the businesses that own the materials, infrastructure, and systems on which that code depends. Technology creates value. Ownership captures it. The ownership shift has begun, and it is already changing where wealth is created. In our next briefing, we examine how this material concentration is reshaping physical geography. Why are semiconductor factories and AI campuses creating entirely new regional economies? And why might the greatest opportunities lie not inside the factory, but in everything surrounding it? This is the Pivot Compass. Subscribe. Position yourself where structural momentum is building. And we'll see you in the next briefing.